Today's lecture is the review for exam number 2. There are total of 18 questions cover the material from chapter 7 to chapter 10. You have 1 hour to finish the test. Therefore, time management is very important. The first topic is involving questions from chapter 7. Giving a normal distribution with mean mu, standard deviation sigma, and sample size n, A, find some probabilities. We need to follow the 3-step procedures to solve the problem. Step number 1, write down the probability statement based on the keywords. If the keyword is in between, then the probability statement will be X bar between A and B. If the keyword is more than, then the probability statement will be the probability of X bar greater than A. If the keyword is less than, then the probability statement will be the probability of X bar less than A. Step number 2, we use this z-score formula to standardize the value of X bar into z-score. And the equation will be z equal to X bar minus mean mu over sigma over square root of n. Note, the equation is not given, so you need to memorize it. And then step number 3, you're going to use the z-table to find the probability. B, recovering the X bar value for the given probability or percentage. And this is an inverse operation of A. Step number 1, we first find the value of z from the z-table for the given probability or percentage. If the given probability is the left tail probability, then we use the table directly. If the given probability or percentage is for the right tail, then we have to use the complement. And of course, for the right tail probability, the keyword will be greater than or above. For the left tail probability, the keyword will be less than or below. Step number 2, we use this z-score formula, X bar minus mean mu over sigma over square root of n, to solve for X bar. In this case, we first multiply sigma over square root of n for both sides of the equation and add mu for both sides of the equation. There's X bar is equal to mu plus z times sigma over square root of n, where z is obtained from step number 1. Topic number 2 involves questions from chapter 8. 101 minus alpha percent confidence interval estimation for mu or p. Case number 1. For the true mean mu, sigma is given. The formula for computing the confidence interval is point estimate X bar plus minus the margin of error z's of alpha over 2 times sigma over square root of n. Case number 2, for the true mean mu, S is given. S is the standard deviation from the sample. Then the formula for computing the confidence interval will be the point estimate X bar plus or minus t's of alpha over 2 times sigma over square root of n. Of course, this t sub alpha over 2 is the critical value with n minus 1 degrees of freedom. For the true proportion p, the point estimate will be p bar, which is the sample proportion plus or minus z of alpha over 2 times the square root of p bar times 1 minus p bar over n. For case number 1 and case number 3, this critical value z sub alpha over 2 will come from one of those three values. Z of 0.05 is equal to 1.645. Z of 0.025 is 1.96. Z of 0.005 is 2.58. The interpretation or concluding statement for the confidence interval is as follows. We are 101 minus alpha percent sure or confident that the true mean or true proportion is between the lower limit and the upper limit. Topic number 3 is involved with hypothesis testing. We will follow the 3-step procedure to solve the problems. Step number 1, state H0 versus H1. There are 3 forms of the testing based on the keywords. If the keywords is different or differ or not equal, we have a two-tailed test. In this case, the set of hypotheses will be H1 parameter or parameters not equal to the given value or reference value versus H0 parameter or parameters equal to the given value or reference value. Keep in mind the claim or the research is on H1. If the given keywords is more than or above, we have an upper one-tailed test. In this case, the set of hypotheses will be H1 parameter or parameters greater than the given value or reference value versus H0 parameter or parameters less than equal to certain given value or reference value. Again, the claim or the research is on H1. If the keyword is less than below, then we have a lower one-tailed test. In this case, the set of hypotheses will be parameter or parameters less than certain given value or reference value versus H0 parameter is greater than or equal to certain given value or reference value. Again, the claim is on H1. Now, what are the parameters? We consider the following cases. Case number 1, 1 mu sigma, the standard deviation from population is given. In this case, we have a z-test. Case number 2, for 1 mu, as the standard deviation from the sample is given. In this case, we have a t-test. Case number 3, we test for proportion p, and this is a z-test. Case number 4, we have 2 means. We testing for mu1 minus mu2. If sigma 1 and sigma 2 are known, and we will have a z-test. case number 5, for two mu's, mu1 minus mu2, S1 and S2 are given. In this case, we have a t-test. Case number 6, we consider matched pair, mu d equal to mu before minus mu after, and this is a t-test. And then case number 7, we have two proportions, P1 minus P2. In this case, we have a z-test. Step number 2, we need to find the test statistic, z calculated value or t calculated value, based on whether or not we have a z-test or t-test. And then step number 3, we make a decision using either the p-value method or the critical value method. For the p-value method, it's an area versus another area, or a probability versus another probability. In this case, we reject H0 if the p-value we calculate is less than or equal to alpha. And now, note, for a two-tailed test, the p-value is equal to 2 times the probability of z greater than absolute value of z-cal. For the upper one-tailed test, the p-value is calculated by this equation, p-value equal to the probability of z greater than z-cal. For a lower one-tailed test, the equation will be p-value equal to the probability of z less than z-cal. And those 3 equations will be given from the formula sheet. Note, for the two-tailed test and upper-tailed test, when we use the z-table, we have to use the complement because the z-table is always giving us the left tail probability. The critical value method is a point versus another point on the x-axis, and the rejection region is on the tails. For the critical value method, we reject H0 if the test statistic is greater than or equal to the critical value on the right, or the test statistic is less than or equal to the critical value on the left. In particular, for a two-tailed test, the critical value will be z of alpha over 2 or t of alpha over 2. Of course, you have plus minus. And for the upper one-tailed test, the critical value will be z of alpha or t of alpha. For the lower one-tailed test, the critical value will be negative t sub alpha or negative z sub alpha. Keep in mind, the critical value for the z-test will come from one of the 3 values. Z of 0.05 is 1.645, Z of 0.025 is 1.96, and Z of 0.005 will be 2.58. The critical value for the t-test, the degrees of freedom will be n-1 if it's an integer, or round it down if it's not an integer. Here is the rejection region for a two-tailed test. If the test statistic is more than your critical value on the right, we reject H0. If the test statistic is less than the critical value on the left, we reject H0. In between, we fail to reject H0. Let's see some examples. The first example is from quiz number 4. Giving a normal distribution with mean mu equal to 32.2, sigma equal to 0.3, and n equals to 4, find the probability that the mean is greater than 32. So you see the keyword is greater than. And step number 1, we write down the probability statement. So it's the probability of x bar greater than 32. Step number 2, we use the z-score formula to standardize x bar into z-score. So you have x bar minus mu over sigma over square root of n. This is letter associated with letter. And then you have value associated with value. 32 minus 32.2 for the mean mu over sigma 0.3 over square root of n. And use your calculator, we get the probability of z greater than negative 1.33. Keep in mind, the z table is always giving us the left-out probability, so we have to use the complement. This probability is equal to 1 minus 0.0918, and the answer will be 0.9082. The second example is also from quiz number 4. Giving n equal to 200 and x equal to 118, set up a 99% confidence interval to estimate the true proportion, P. For a 99% confidence interval, the critical value z's of alpha over 2 is equal to z's of 0.005, which is 2.58. The confidence interval has the form of point estimate plus minus the margin of error. In this case, the point estimate is the sample proportion P bar, which is 118 over 200, and the margin of error is the critical value times the square root of P bar times 1 minus P bar over n, which is 2.58 times the square root of 118 over 200 times 1 minus 118 over 200 over 200, which is equal to 0.59 plus or minus 0.090. And to get the lower limit, it's 0.59 minus 0.090, which is 0.5, and the upper limit is 0.59 plus 0.090, which is 0.68. Convert this into percentage. We have the following concluding remark. We are 99% confident that the true proportion is between 50% and 68%. Example number 3 is from quiz number 5. Giving a set of hypotheses H1 mu not equal to 50 versus H0 mu equals to 50, the level of significant alpha is 0.01, sigma, the standard deviation from the population is 16, n equals to 81, and the sample mean equal to 55. I ask you to test the hypothesis. And step number 1, we find the test statistic zcal, and then we need to make a decision based on the critical value method. So we use the equation zcal equal to x bar minus mu 0 over sigma over square root of n, which is equal to 55 minus 50. That's the right-hand side value, mu 0, or we call that the reference value. That's the numerator, and the denominator is 16 over square root of 81, which is 2.813. Now, to find the critical value, notice this is a two-tailed test. So the critical value is equal to plus minus z's of alpha over 2. Alpha is 0.01, so alpha over 2 is 0.005, which is plus or minus 2.58. And then we draw this x-axis, put the 0 in the middle, and we write down the critical value. On the right is 2.58. On the left is negative 2.58. Now, zcal is 2.813, which is more than your critical value on the right. So we reject 0. And this, we have evidence to say mu is not equal to 50. This question is from quiz number 6. Giving a set of hypotheses h1, mu1 minus mu2 not equal to 0 versus h0, mu1 minus mu2 equals to 0, the test statistic zcal is equal to negative 2.13, alpha equal to 0.05. Find the p-value and make a decision based on the p-value method. The p-value is equal to 2 times the probability of z greater than absolute value of zcal because this is a two-tailed test. This p-value is equal to 2 times the probability of z greater than 2.13, and notice the z-table is a left tail probability. We need to use the complement. So the p-value is equal to 2 times 1 minus 0.9834, which is equal to 0.0332, and alpha equal to 0.05. There's p-value is less than alpha, and we reject h0. I would like to bring to your attention the following important note. Note number 1, you must use Proctorial for exam number 2. Therefore, you need to set up Proctorial on Blackboard. There is a link on the new syllabus for installing the Proctorial extension for Google Chrome. Note number 2, before exam 2, you need to print out the following. 1. Formula sheet for exam 2. 2. The T table. 3. The Z table. Note number 3. The exam is taken using Proctorial on Blackboard during the scheduled class time. The test will not be available any other time.